Yes. Okay, so now I am recording. So welcome the Colliers team and a number of the folks that came on the 29th. Tara, I will hand this over to you. Thank you so much. We're really excited. Once this is recorded and uploaded, it'll be on our YouTube channel. So I'll send everybody the link. Thank you.
Okay, great. Can everyone hear me okay?
Mm-hmm.
Okay, perfect. I'm Tara. I work with Colliers Engineering and Design, and some of you we saw about a month ago when we kind of did our drone presentation. So the idea behind this, and again, I want to thank Addie for helping me set this up, and obviously great to work with for this, was that a lot of architects, we get brought in for like, I need setbacks, or I need wetlands, I need maximum lot coverage calculations. So we kind of were just getting brought in at, if needed, kind of towards the middle of like a design of a project when they absolutely needed some information they couldn't get around not having a survey for. And one thing I was kind of noticing was that there were ways that we do things that I think could improve architecture processes. And a lot of our architecture clients would say like, oh, I wish I'd known this at the beginning, or I would have liked to be able to do this, but now I'm halfway through the project and it doesn't make sense to kind of start over. So just share some information about the technology that's been evolving and how it can be used to kind of in architecture, and how to bring like the three-dimensional environment in. So I'm gonna stop my camera and then go to the presentation. So this is the follow-up of what we did in April, and just a little bit about us and kind of what we'll be talking about today. We're gonna go over static scanning, which is what we did at the brewery, and then we'll go over drones and UAV, and then Todd from our team is going to present about visualization and how the scanning and UAV data can be used to do the three-dimensional visualizations like fly-throughs, rendering, that type of thing. So first, a little bit about our kind of our scope of services. As I said, we do boundary surveys, but we kind of go a little bit beyond that. We do land development, site plans, floor plans, mobile and static LiDAR. We also have done a little bit of different types of survey. And then we also do point clouds and feature extraction. So basically, if it's spatial data, we do it. And yes, we're all surveyors and we have a good understanding of like boundary law and that type of thing and survey control, but it kind of goes a little bit beyond the flat two-dimensional plans now, and it goes a little bit more out. So our survey approach, we use pretty much every tool. And if there's a complicated spatial problem, we like those. And we like to see like what tool can we use for what job? And then also like, what is an appropriate deliverable for you for this job? So yes, sometimes the best deliverable is like a more simple plan. And sometimes the best deliverable is a much more complicated result, maybe a rendering, something like that. So kind of we use all the tools to help our clients get where they need to go. So the first thing we're going to talk about is static scanning, and I'm going to stop sharing. And a coworker of mine, Devin Hurley, is going to take over and kind of talk a little bit about static scanning and show the data from the brewery. So I will stop sharing. And then Devin, I'm going to go ahead and mute myself because we sit next to each other.
Gotcha. I'm going to try to share my screen here. Can everybody see that? This is a blank screen right now, but
Yes.
I was going to pull up what we did. Okay.
Yep. We can see it. Thanks.
Cool. Yeah. So this was the first scan that we did, which was just like of the exterior of the brewery. I just did it from one setup, but just kind of wanted to give you guys an idea of like the level of detail that we're able to get from these things. And so you can see, like, obviously you can make out that text, but really like the front, like the face of the building had, I mean, you can see like the grooves in every one of the, not really bricks, but whatever you'd call the face of that building. And I mean, that's just kind of the level of, I think I had this cranked up to like, there's about 50% of like what we're capable of with it. So basically, yeah, we can get as much detail as you would ever need. In most situations, we end up like dumbing down the point cloud by about, we try to get an average spacing of like 1/10 of a foot or something, just to make it more like manageable from a data perspective. But I mean, that's basically a picture in terms of the amount of detail that you got from it. The door was open, so like you can see where like people were drinking beer at the bar and stuff. Yeah, and then a lot of times we take this point cloud and we try to extract like using Revit models or whatever to basically like take like the face of the building, rather, you know, extract the face of the building from the point cloud and things like that. An example of that, I just took this tree as an example. You can create like a cylinder from it, and so now you're actually creating this object like three-dimensionally. And yeah. And then just as kind of like a, you know, to show you kind of what we have to do. So like to tie, we do, this was just one scan, but in general, we do multiple scans. We basically have to stitch them all together. And the way we do that is you have to have these common targets that are visible from all of the different scans. So, I mean, just kind of a little fun fact that you can see, this is actually a sphere, and we know like exactly what the radius is, and this thing will automatically like pick that up and know that that's a target. And it just has a magnet on the side, so I just attached it to the building right there. And there's a few of them that I placed around. This one down here. Yeah, so that's kind of the deal from this scan. And something else that you can do that's kind of cool. You can change the way that you view the object. So point cloud. So I'd forgotten to take pictures with this one when we did it, but you know, you can kind of change the way that's coming up with these colors is based on the intensity of the return. And so it really does give you like an idea, you know, it kind of like the different colors and stuff, it reflects differently. So, I mean, you can see like the grass looks, and then that you can make out those pavement paint lines. You can see somebody had painted something over here. Yeah, just kind of gives you an idea on that. And then we scanned the group instead of taking a picture. We, you know, scanned everybody in, and Logan started over here, and then while I was scanning, ran to the other side, so he's in there twice. But yeah, just kind of a cool thing.
And then Devin, I have those before and afters in the PowerPoint I can show that.
Okay. Yeah. Pretty cool stuff. And then because I forgot to take pictures, I figured I could just grab another scan job that we did, so you can kind of see what it looks like. So we scanned, this is the 99 in Augusta, and you know, we took like full pictures with all this, so you can actually make out, you know, exactly what everything looks like on the site. And I mean, again, the purpose of what we were doing here was like all exterior existing condition survey, but I mean, you can see the level of, like, normally this isn't something that we would care about, but all this data is in here, and the level of detail we have is like, it's pretty impressive, you know. And the shared parking lot with the hotel, and I mean, you can make out, and again, this was not like what we were doing, but just because we scanned it, you can see everything, you know. So yeah, that's kind of the examples that I have. I'll probably stop sharing now unless anybody has any questions. All right, then Tara, I'll hand this back over to you.
Okay, so this is, I wanted to show some before, so that's just the raw data. That's, we process it, we, you know, do the survey control, we show the targets from every position, and then I just wanted to show an example of what it looks like after it gets modeled. So this is another project that our company did. And then this is a photo of the exterior of the building. This is the colorized point clouds. So you can see this one was done with, that's the intensity return is like the bright colors. And then each pixel gets like a photo assigned to it or color. And then this is what it looks like as it's been modeled. So you can see that's a photo of the front, the raw point cloud, and then the model. And how detailed the model is comes into the level of detail for the scope of modeling. Because I'm sure, as you all know, the more you model, the more you add. So that is kind of a little bit of a simpler model, but it does show the level of, I think it's cool to see it from photo to point cloud to model. So, and then there's our group photo, the actual photos up top. So you can always say, if you don't photograph well, maybe you'll scan well. And then next, Richard Kusaba from our office is going to talk about the UAV aspect of it. So I'm going to stop sharing and let him jump on.
Hello, everybody. Let me get my share going here. Is that the one? That's the one. My name is Richard Kusaba. I'm the CAD manager here in the Brunswick office of Colliers Engineering Design. I've been in the survey business for about 20 years, both in the field and office. I had a previous 10-year career in software development. And I personally process maybe about 65% of the LiDAR and aerial data that comes across, with about 50% of the scan data, such as Devin was just showing you. For the next few minutes, I'll be doing an overview of some of our aerial processing steps to show you what kind of data we can get and what we can do with it for you. So looking at, my screens are split, so I'm not going to be looking at you, sorry. First of all, we take drones and we run them in the sky, as you know. And there are two forms of processing we do. We do either laser-based or we do photo-based. For the event on the 29th, we were doing photo-based. We ran the bird in the air and took several photos, a whole bunch actually, about 100. This is a photo from a different job. I'll be showing you some of the photos from Portland here in a minute. This is a nadir photo, which means we're looking straight on down, which compresses the three-dimensional part of it, but you get a good idea of where stuff is on the ground so you can do your mapping of it. This is where we do the traditional survey, identify things like your roads, your building peaks, and so forth. From the air, we can also do oblique photos, and this is really great for capturing the three-dimensional up to down of your buildings, of perhaps your TV antennas if you still have those. And these are the kinds of photos that we shoot from the air as we're flying the plane up there. Now, after we get a whole series of photos from the air, we can marry them together in such a way that it produces an image as if you were looking straight down from above, no matter what angle you're looking at it. It won't be oblique at all. We call those an ortho photo. And this, again, is the combined ortho photo from that previous job. And then our other technology is laser-based. It's called LiDAR. And this is the LiDAR image that comes back. It's the same. You can still see your building here. You can see the LiDAR return. And with this, we get intensity of the return. We can pick up some texture values and so forth. And we get three-dimensional. Basically, we get a whole lot of three-dimensional spots, several millions of three-dimensional spots in the air. And from that, we can do modeling of the ground. We can see where ditches are. We can see where various ground features are. Not as good as the terrestrial stuff, but very, very, very fast and very, very, very safe. Now, the data doesn't stop there. We have the ability to marry together both the overhead ortho photo and the LiDAR data. And in this case, what you're looking at here is the LiDAR data from before with an extra added dimension wherein we've added the color of the photo to the spots, which helps the office people in their extraction. They can go and say, okay, this bit of cloud is clearly edge of road. This bit of cloud is clearly edge of road. We've got a roof peak over here. We've got a car over here, and so forth. And that's a little bit of what we can do with some of the aerial data that we collect. Now, at Portland, we flew the drone. This is the path that the drone took. Now, the the fly people are very versed in FAA regs and so forth, and they set up this flight pattern. And this is the pattern it flew over the center and over the ball field. And that's what it did as it was collecting the photos. Here are a bunch of the photos that it actually collected. You can see the building here, a little bit of the road here. And then we were able to marry all of those together into a single ortho photo like the one here. Now, this is a completed ortho photo looking straight on down. It was fairly flat. You've got your road and you've got the parking lot and so forth. And for those who were there, that was a very, very quick, just a quick flight, and they took care of it. So while you were there, you got to see both the terrestrial data that we were able to collect and get very, very, very detailed stuff at the building level, at the interpersonal level, and we can also grab data from up above on a broad scale. And even on that broad scale, we still get some three-dimensional because we have our oblique photos. So yeah, it's a matter of using the right tool for the right job, and we have a full tool chest to work with. And that's my presentation for the moment. I believe we can hold questions till the end, and I'll go ahead and hand back to Tara, who's being our MC today, and she'll go ahead and take her over to Todd next day. And thank you very much for your time.
Thank you, everyone, and thank you, Tara. Thank you, Richard, and Devin, and Todd. That was.
Oh, yeah. So Todd's going to go next, actually.
Okay, great.
Yes. Yep.
Hey guys, got me okay?
Yep. Go ahead.
All right. Let me find the right window to share screen here. Got that okay? Looks like everything's fired up correctly. Good to go. So yeah, I'm Todd Heckerman. I've been doing visualization for 15 years now. Started in 2006. So I've seen, the day before Revit when every building was in 2D and every wall needed to be extruded to see in 3D, and some of the amazing strides and advances that have come across over the years. And some of the UAS scanning is some newer, really cool stuff. So it's actually really exciting to be able to take advantage of some of it. And there's an example that we can dive into a little bit more at a golf course here, where a part of the design that was being looked at was and I don't know the correct terminology for. I believe it's where they come and pick up their pencils and their guide to what they're going to do. I'm not sure the name of this type of shack, but it's going to be a new new design, new build on the course, and people were obviously very, very interested in what that would look like on the course, and it was really cool to use a drone scan to construct photo simulations around that. But then I'm going to get ahead of myself a little bit here. To start with, we want to look at get my arrow button to work here. There we go. So the inputs. I want to start with the inputs that I take into the visualization programs, and just to throw out some programs. My main program is Autodesk 3ds Max, where I work on most everything. For rendering, I use V-Ray most of the time. For real-time, that's a game engine development environment called Unity. Some dabbling in Unreal as well. But so a screenshot here is kind of, for instance, that's in 3ds Max. And looking at some of these inputs, as far as vector-based, line work, contours is something I get out of UAS scans often as far as the line work goes. I actually have obliques for camera projection modeling and line work incorrectly, but separately obliques for camera projection modeling, which are the photographs. And actually, Richard, they had a slide that had an oblique, one or more oblique. So those can be a great input as well. Then there's the existing models that were captured at the time. So those can come in the form of meshed UAS, LiDAR and photogrammetry captured based models, which I think Richard mentioned you guys flew photogrammetry kind of style flight on that one. And actually, I don't have any. My examples, unfortunately or fortunately, are separate projects. I don't have specifically what those guys flew, but I think, you know, the point is the same regardless. And point clouds can actually be, although, you know, traditionally you don't see a lot of point clouds in Viz, graphics cards are highly optimized to display triangles very, very quickly, and they're not highly optimized for displaying millions and millions of points. But they are, you know, as we've probably seen, it becomes a input into the design process probably more than the Viz process. But, you know, not to say you can't still use them, and, you know, I do have a bit of an example of that. And then proposed, you know, outside the, you know, the UAS scanning, the existing capture stuff, the proposed models, we'll bring in, you just about name it, Revit, SketchUp, you know, there's 3D CAD that we still occasionally get, Rhino, I work in Blender sometimes too, you know, those 3D models can come in from a lot of different places, and I'm sure architects are aware of, have heard of Entourage, you know, it's the kind of model library that you kind of pull from. So, you know, we'll have a library from various services, V-Ray, Chaos V-Ray, has Cosmos service in Enscape. You know, you'll have a giant catalog you can drag and drop in. Lumion, you know, they all have their own, the kind of library that you work with. And then for me, just having been working in Viz for, you know, since 2006, we have a bit of a library of our own, you know, over the years of models that we created that we can kind of go back to. I know some, you know, some architects in you know, SketchUp and Revit can also kind of hark back to some previous models, and then, you know, kind of use them as a starting point too, and a similar thing to the side. And there's some of it's just bespoke hand model things that no one's, you know, newsflash, not everything in the world has a 3D model, you know, yet. Occasionally you do have to actually, you know, model something from photographs, or use some of that photogrammetry stuff like we've done on a couple sculptures as well. And, you know, there's the US flights that give us a lot of other data. So to come out of inputs and then looking at some outputs, PhotoSims is, you know, a really large part of some of the stuff that I do, especially more recently too. So you can consider them before and after comparing photographed and proposed states. Your precision still video camera matching, and ground or the air, by the way. So you're saying, you know, here's an existing state, here's the proposed state over the exact same camera properties, so that it appears to sit right on top of the photo. I mean, looking at, you barely have to describe what it is, and you could just look at it, you know, you see what it is basically. But yeah, a lot of approvals are based on this. You know, the town board, the neighbors are concerned about a project. They want to see what it's going to look like across their, you know, across their driveway in a lot of cases. It's kind of a high fidelity mixed reality. If you think of augmented reality, like the HoloLens, you know, you can look through this kind of goggle and then overlay 3D onto that. This is almost like that, only we're just in a single still frame, you know, one single photo for one single specific place, but you can get a nice high fidelity out of it. I should probably get that out of the way. Sorry if that was distracting, guys. Yeah, so then looking at some of these examples, up here we've got a Circle K that was getting demolished and replaced entirely. So there's that existing photo, and then the proposed is the 3D model, and that's a Revit model that came in with some of that entourage I used from, you know, Chaos. In my case, Chaos Cosmos, trees and cars and such. That one provided an additional challenge because the person who took the photo existing had done it right after a rainstorm. So all the reflections in the roadway I had to deal with because they were reflecting, you know, what was not supposed to be there anymore. So, you know, I had a little bit of work, but, you know, I kind of like to do this stuff. So that was also fairly entertaining to come in and replicate, you know, those reflections on the ground, which kind of needed to be done to make the photo believable. Jumping down here is a good UAS. And previously, and we'll look at a model here, but I did use actually a point cloud from US overflight on this one to help me line up the photo. But jump over here. You know, clearly this is an aerial shot. Single kind of one photo, one place again. But it's a great shot of this entire body of water. It's for a project where they were doing some draining. I forget why they were draining this body of water, but we did renders I believe it was every 5 feet, showing the reduction in the water level. So, you know, there's obviously a lot of concerned people wanted to get an idea of what that was like. And, you know, I think, you know, being able to show this to them, even though, you know, they may still take issue with it, I think is better than maybe looking at a whole bunch of plots and, you know, engineers talking about stuff and they still, you know, you might get some grumbles still. And, being able to see it and kind of digest it in a way that the public might be more used to seeing things, I think is helpful in and of itself. And then over here in the solar farm area, this is, solar farm stuff has been pretty huge. I've been doing a lot of these lately. It's almost always a cornfield that turns into a solar farm, and this is actually in someone's driveway that I took that photo. So they're obviously extremely interested in what that's going to look like, and it often involves screen trees, and we need to have a nice presentation of the site for the people who live right there. So that's another thing that will go into this often. So that's one kind of output. PhotoSims, a big one, and then moving into real-time simulations. So when I spoke about using Unity, that's a game engine that you can kind of custom build, bring in models, C# code your own kind of interface menus, and a lot of stuff can go on there. But we do have a great example of that actually, which I could share the actual model with it in a minute here, of a roundabout project. And there's the existing, it's that whole kind of existing proposed thing happening, and be able to flip between the two. And it was and this is actually just a Phantom. It wasn't a super fancy one, but it's amazing even at that level you can get such a cool result. And for the viz, it's not the engineering grade. A lot of what those really dense point clouds that are required to really accurately model as built and do all that stuff is is incredibly useful. But just even that meshed output of the result is really useful on the viz side. Bring an entire environment in, like boink, there it is. And I had to kind of treat this a little bit extra. You can see it's not, if you look at the kind of tessellation, it's very evenly tessellated and sort of quadified, which is what you'd like to see for graphics cards. I'd like to see that because the guy that was running this was on a decent laptop, but it needed to be kind of resurfaced, retopologized a little bit for it to run correctly for them. So there was some pre-processing there, but for people who have high power graphics cards like I do, it's really neat to bring stuff in and just have it be there. Super cool stuff. But yeah, underlying game technology. In the past, have actually, we've had a project, and I just sat there as like a guy at a kiosk, and public was free to just come up to me and say, "Hey, what does this project look like for my house?" And I would just kind of go over there and we take a look. And some of that is kind of on the bottom. A couple shots I have there, University of Rochester, or the city of Rochester's in the background. We've got some pretty big models, and there's the city of Rochester itself with some kind of sub projects that are in it. And this might be a very large scale, big free to public use LiDAR. And then once we get into some of these sub projects, you might see UAS scan data being used, survey at ground data. It brings in a lot of, being a viz guy, you end up seeing a lot of different types of data, get them from all different kind of disciplines. A little time check, how are we doing? Not too shabby at all. And that was actually my last slide as far as slides go, and I wanted to jump into some of these models. If I were to back it up, there we can actually jump into this model. Let me flip. If I can get us in the right one. I've got a few windows open, guys. So this is actually the mesh data in combination with the Revit model data come in to kind of create the photosims that we used to present. It was actually the golf club. It was a rather prestigious golf course and club. People very, very interested in how this would look on site. So it was very important to come in with some good and accurate looking shots. And yeah, so this is an actual direct drone scan data that came in from, and this was some years ago, and I forget if it was Pix4D, if it was context capture, but it was one of the above kind of meshification, drone data processing software. One of the outputs is it can be a tessellated mesh like this, and textured as well, so you actually get the textures on here. And oh, not the model, sorry guys. Yeah, well, this is a new Zoom thing for me. Maybe I'm gonna have to do a different screen share type thing. Let me shut that down. Oh, so maybe this isn't the. I'm used to the whole window being shared, and then I just alt tab. Sorry about that.
Yep, no worries. I was just going to Teams you, but I think you got it.
I did. Thank you very much. I think we're probably good now.
Yep, perfect.
Okay, there we go. I will remember to do it that way next time. Sorry about that. So you probably were like, what's this guy talking about? So yeah, this was this was the model that I was just previously talking about. Yeah, so the drone scan, it's this entire kind of monster, and you could see the Revit component that came in was the actual design. You know, and this is actually interesting because there is a bush, and you can kind of see where the edge of the grass is, and there's like another kind of feature here that they were replacing with this other little tiny building used for golf, and it's right at the kind of literal fork in the road where you decide like which course you want to go to. So they pick up I think they pick up their pencil, do whatever at the little pavilion, and then go on to the course. And actually, I just noticed that I'm in the scan. Here I am over here actually flying this thing. It's always fun when you see yourself in these things. But yeah, and I don't have to kind of re-talk about what I already was saying, because it was obviously very important to get this all photo simmed up for the club members. So then I would put in Photoshop. In this case, in Photoshop, brought in the actual photographs that were taken that kind of match generally, you know, the shots. You can kind of tell here we're up at, you know, there's some kind of deck or balcony or something. So like an accurate shot for us, and we were able to come in and photo match those all. And these are all kind of cameras that are in the 3D scene, so that I would render separately and photo match them to the background photo. I'll check on time. Doing not too shabby. Probably move to another model here. And I need to stop sharing there, and we will share another screen. Actually, yeah, I don't actually see the window that I'm going for in this. It's a bit odd. You guys see this right now?
Yes, I can see the golf course. Oh, there it is.
Do we just flip?
Yes. Yep, now it's a
Okay.
Circle K.
Yeah, that was odd. Sorry, apologize. Not super used to Zoom. We'll jump right back in it. Now, unfortunately, this model, when I went to crack it open this morning, was crashing on me, and it's from a previous version of 3ds Max. So I had to scramble a little bit to kind of basically reassemble it for you guys. But you know, the overall vibe of it is, and I think I can still flip back to. You guys see the presentation?
Yes.
Yes.
Okay, yeah. So I'm kind of free to move about now. That's just kind of what's going
Mhm.
for. So that right there is the, you know, the fully assembled scene where you can see kind of the CAD file is in there. The point cloud is surrounding. You can see right there the camera that was actually used for that, you know, for that render right there, all assembled in the file. So generally, once we're in here, you can kind of get a vibe for how, you know, even this is point cloud. This is points, just like kind of we were seeing earlier. I was able to, and this isn't a perfect match because I did have to scramble to get this thing in here this morning, just for our example here. You know, I could, if you picture this all, you know, actually having been lined up, you know, that pole would be right here, the corner would be the corner. It would help me when I'm, you know, actually manipulating the camera in another view. And there's that camera that's actually used for the photo sim. You know, I can come in there and go, I get, you know, a little, if you look at the bottom right screen, okay, right about there, you know, and then just kind of squeeze things around after having initially matched the sensor size and the lens focal length. Those are the two primary things, but usually there's a little bit of fudging around to get to the right spot. And I got to say, it was super helpful to get that UAS data in here as an, you know, kind of like an augmentation to my camera matching process. And that was really super handy for that project that we were looking at before. And then to zoom over to some of the solar stuff. So this is a solar project in New York, and this is kind of an example of some of the contours, you know, getting used for viz. So in this case, it's forming the terrain and the 3D mesh that I'm gonna, again, we're photo simming here, so I've got cameras laid down where some of these people's actual properties were, and in some cases they actually gave us the photo, and the town, everyone agreed that, okay, we'll photo match from your photo. So there's some that are on people's decks. Yeah, that's one that was actually on the back of someone's deck. So this, goes into that, very important terrain model for this, to where I can actually come in and put a camera on the ground, put it 5 feet above the ground, 5 feet 5 inches, the average human height or whatnot, and start with a very close proximity of what is a good camera match. And then, maybe there's a little, slide around a little bit, get her, right about in there, and yeah, boom, you got it. And then, at that point, this camera is locked to the background, and any kind of 3D modeling or, whatever I'm doing in here just becomes kind of locked into the perspective of this camera. I've done these with close proximity ones, like it's really close to this person's yard. But we've also been asked to take shots like miles and miles away just to confirm that you won't show anything. And I've literally rendered a solar farm like at the top of a peak of the side of a hill, and that goes into the, the whole package that everyone checks out at the end. And a little example of that is kind of the end result of some of those. So there's that guy's deck with his view of what the project's going to be, and of course the concern there being, ooh, that's a lot of solar farms. So, you come in and say, oh, well, we can provide, screen trees, and by the way, here's what they would look when they're planted. In 5 years, they're going to look like this, and this is all goes into satisfying the public that this project is acceptable to visually, the impact wise. So it's something that you tend to see a lot. And actually, I think I really nailed the time. One of the last thing we got to get into it quick here is we're at 12:40 already, is the real-time model stuff. So this is another example of an actual UAV scan. This is the full scan that we've got here, and put wireframe on kind of tends to help of existing. So this is an existing site that was used to present a proposed condition. You can see a lot people are concerned about as you come in down the road. This terrain is making it hard to see. Oh, there's a roundabout. So basically, the only reason people would know there's a roundabout coming up, is what signage is there. So they use this to map out, hey, alert, and these will actually flash, and they'll show like flashing lights, and then coming from the other side, there was some kind of a cool idea that one of the guys had, and I'll flip. When they're actually presenting with folks, I made a little button that they can just flip quickly. But here, for what we're doing, I'll just do it manually inside here. So they would push a button, and it would sort of flip on the proposed state. And then actually, they additionally proposed a little bit of landscape here. And I think this is such a cool idea. So as you're approaching from this side, you're getting kind of a warning that, so someone coming up will see that straight ahead of the road, and maybe, thought being, maybe they're paying a little more attention. Maybe it's an additional cue that, maybe you get off your phone and take a look at what's happening ahead of you. So the thought was to kind of prompt them into paying more attention in addition to the signs. So I thought that was kind of a cool idea, because it's literally straight down the road. If that road didn't bend, you might think you're heading for those trees. I thought that was pretty neat. But yeah, this entire thing was based off of UAS scan. This is Bentley microstation happened to be used for the proposed portions, and then we just flipped. So I just kind of stitched, where the new stuff happened, stitched in the old stuff. Another cool thing with the UAS is the resolution of the ortho photos and the aerials that you get, and just super cool when you're building something like this, and you're gonna go fly around on it and be very close to it, to have the the mesh texture at such a nice high level is really helpful. And even just for stuff like when I was dropping an existing stop sign down, I could literally see where the stop sign was and put it there, and it's been super handy so far. So yeah, so I think that was. I probably have one more thing about just really quickly using ortho photos to projection model 3D. This is something you might want to Google further if in your own time, and it might help you separately for creating buildings on the periphery of your projects. So high-res aerials can actually be used to, in a more traditional photogrammetry way, kind of build out some of the geometry. And again, for viz, for populating surroundings, I don't think anyone's going to come in and use this model. It is, engineering grade. kind of basis or anything, but for purposes of this, certainly those obliques that you get, really high res obliques, are really cool for doing stuff like that. And then you extract that building out of there, and now you've got like this texture building of what was projected onto the background there. So we'll leave it at that, and I think that should wrap it up for me. Stop sharing. Should be back.
Yeah, thanks, Todd. I think that was great. So I kind of was really excited Todd was able to join us for that, because I think sometimes it's like we can do all of this, but then what does that actually mean for our clients, and what does that mean for their clients? Because our job as surveyors is mostly to give you information in a usable way. And I think being able to use the data we can collect and then bring in the visualization component makes it a much more usable communication tool, because surveyors, essentially, we're supposed to communicate. We're supposed to communicate spatial data in a usable format. So I don't know if anyone has any questions. I'd be happy to answer those.
David, it looks like you're going to ask. Yes.
Yeah. I had to figure out, remind myself how to unmute. Yeah, for the fascinating stuff, first and foremost. But for the survey, for like a topo survey, does the technology see through the trees to get to the ground contours? Like if you've got heavy tree cover, and how does it know to do that?
If I might on that one, Tara, for the photogrammetry, no, the photos don't get through the ground, but that's where we bring in the LiDAR, and the LiDAR does find enough space to get down through the trees to pick up the ground surface underneath.
So it's just like it looks between the trees or
between the leaves,
something like that.
It's pretty impressive.
Yeah, it's amazing.
Okay,
thank you.
It's actually a multi-return system, so it's going to hit the canopy first, go back to the unit, then go to the next lowest feature that it's going to hit, back to the unit, up to 5 returns. So you can see how it would make its way through the tree canopy within 5 returns all the way down to the ground. You'd have another level of undergrowth, vegetation, that sort of thing.
We've come a long way.
Yeah.
Hey, what is the time between returns? Like, how fast is that happening?
That definitely depends on the unit, but faster than we can comprehend, because it's picking it up from the same location as this unit moves. The laser spins so fast that it's similar to a terrestrial scanner where we're picking up, able to pick up 2 million points every second in some cases. So you can imagine how fast those returns are.
Yeah, so John had asked a question in the chat, interested in acquiring raw data for renderings, and is wondering if there is a way to ballpark cost. So the answer, frustratingly, to that is it depends. It depends on the size, the scope, the location. If you would like to email me afterwards with like some specifics, I'd be happy to provide those. Typically, what adds a lot of cost is rendering. So a lot of companies do that in-house, and what we'll provide to them is like an accurate point cloud, and then they'll render it. So that's definitely something we do, but ballpark cost, it depends so much on the project, if you need interior, exterior, the size. But email me and I can get you some rough numbers. Thanks, Eddie.
One of the challenges with dealing with this type of data as well, we see this from time to time working with architecture clients or whoever may be digesting the point cloud data resulting from whether it's mobile scanning, terrestrial scanning, or UAV LiDAR. They're all different forms of point clouds. The files can be extremely large. They could be as large as 100 gigabytes of data. And that's a barrier to utilization. And that's really where we're able to continue to help is we have the software capabilities to digest that. But as Tara mentioned, when you get into renderings and modeling, there can be a cost associated with that just due to the level of effort to work through that data. But usually there's a solution, and that solution is derived from having a conversation about what the end goal is, because there's a lot of different ways we can approach it and different levels of detail, and knowing that is the way to price something.
Awesome. Well, I'm grateful, guys, for this program. I think both in the field and then the wrap up. And again, for the folks that RSVP to come today, I think they'll really enjoy the presentation, the recorded version. But it doesn't mean that you are strangers. I'd like to maybe check in and possibly do this again, because I think it's really incredible. So I'm exceptionally grateful. I also know that the brewery would like some of the imagery, as would the Portland Parks Department. So if we can give that on over to them, that would be awesome. And yeah, and also if maybe we could compile all the presentations just in still images, that I could have that available, that would be great.
Mhm.
So
Yeah, I can send that to you.
so give me about 24 hours before I can get this on a YouTube. And yeah, thank you so much.
Yeah, thanks.
I
This has
will,
been great. It's a good
pun
learning experience
intended,
for all
I
of
will
us.
see you in the field.
Yeah, sounds good.
Thanks very much for the opportunity.
Yeah, thank you so much, everyone.